Yo, what's up, guys? Welcome to um, welcome to watching our QBUS5002 live streaming session, live streaming consultation for your mid-semester exam. Let's see how many students are here now. Oh, 0 is watching. This is interesting. Is it watching 0 or you haven't see your email? Okay, 14. All right. So as I mentioned in the announcement, I will be covering basically two things of today. Why the light is so dark? I hate that. Can it be brighter? No. Anyway, so today we'll be doing two things. First of all, I'll just give you a general overview of what we're gonna cover. Not what we're gonna cover, but what we have already covered in the first 5 weeks, and some key points I think that are important for you to understand. In terms of the details, I believe I attached the 3 links of 5001 mid-semester exam review. I believe they will be enough to for you to do your revision. Okay, so I won't put too much details on here. And the second thing, which contains the most part of today, is to answer your questions. So I believe your exam will happen on Saturday, so that if you haven't started doing any revision yet, then you're gonna be in trouble, right? So I reckon most of you have finished at least some of the revision, and you must have a lot of questions that you want to ask. Therefore, another part of today is a Q&A or consultation, as I said. This is for QBUS5002, okay? But I do have 3 links I posted on eDay for 5001 revision, and they are basically the same thing to QBUS5002, because the course coordinator is Boris Choi, and it's the same person as 5001. So in terms of the knowledge, they are the same, or the type of questions will be similar, but some knowledge coverage might be different. Okay. All right. Now let's first look at the overview of the first part of the semester. So in this part, I'm just going to briefly illustrate what are important, or not are important, but what we have learned. Okay, I don't know what's gonna happen in the exam, so I will just share with you my experience in reviewing the first part of the semester, or the mid-semester exam. Okay, so the first big topic is about the descriptive measures. So in this part, I'm pretty sure most of you have already learned it in middle school, high school already, right? So you learned the measures of central tendency, which are the mean, median, and mode. Yeah, the exam is about week 1 to week 5, exactly. Central tendency, and you also have variation. So the variations, the measurement of variation can be variance, standard deviation, range, or even interquartile range, that sort of stuff, right? And that's all about variation. And you also get CV, coefficient of variation. And also we have the measurement of association, which are the covariance, and correlation coefficient. And lastly, probably not lastly, but as far as I know, lastly, we've also got the relative standing, the measurement of relative standings, which are, the quartile. So we first have percentiles, and then we got quartiles. That sort of things, right? And we also have interquartile range for the measurement of variation or relative standings, right? So interquartile range. So as you can see, here is just a list of what you need to know for your first part of the semester. Okay, we learned about the descriptive measures basically in week 1 and 2 probably, and here are the different ways of describing the feature of data, and you need to know how to calculate them, how to apply them, and how to interpret them. Okay, so that's all about the descriptive measures. And secondly, we also learned a lot of graphical descriptive measures like bar chart, pie chart, but those charts are just super easy, right? So I won't say anything about that. They are just the name of the charts, right? And the second big part of this semester is about probabilities. So in terms of probabilities, the first thing that you need to know is about events, because probability is actually describe the likelihood of an event to happen. Therefore, for any events or in any probability question, you should first identify events within the question. Okay, so if you have a question asking you about the probability, the first sentence you have to write is, for example, for example, we are talking about flipping a coin and getting head or tail, right? So we can let H to be flip a coin and get a head, and let T to be flip a coin and get a tail. Then H and T are just two different events, right? They are events. So the first thing you need to know is that probability is describing events. So we will denote the probability in this way. For example, the probability of H will be denoted as P bracket H. H is the event, okay? So here is the event, and this stands for, the big P stands for probability. Okay, so probability and event. So we know if it is fair coin, the probability of getting a head is 1 on 2. Okay, so that's the first thing you need to know. Probability describes the feature of events. Secondly, in terms of probabilities, you need to know the 3 different types of probabilities. We've got marginal probability, we've got conditional probability, and joint probability. So you have to know exactly what those 3 things are. Especially from my experience, you can be given a table, a probability distribution table with different results, A1, A2, this is B1, B2. It can be any event, like male, female, passed exam, not passing exam, that sort of thing, right? And you are given different either proportions or probabilities or the total numbers, right? So if you are given numbers, you have to divide it by the total numbers to get the relative frequency. But if you do get a relative frequency, you need to be able to correctly identify 532, 0.11, okay? You need to be able to correctly identify what the probabilities are they, okay? So within all those tables, they are joint probabilities, right? So those probabilities are the probability of A and B, right? A and B, both of them are happening together. And if you calculate the total on those margins, right? So this is 0.6, this is 0.4, and this is 0.8, this is 0.2. So if you consider all those probabilities on the margin, they are actually marginal probabilities. So it describes the probability of one thing happen, right? Regardless of the other stuff. Therefore, this probability is denoted as a probability of A1, right? A1. So this one particularly is A1 and B1 happening together. And lastly, in terms of conditional probability, for example, if we already know somebody is a male, for example, this is male, okay? And what's the probability of, pass, not pass, female, no, this should be female, yeah, otherwise I will be involved in discrimination, right? So this is pass the exam, not pass the exam, okay? So female, if we already know somebody is female, what's the probability of passing the exam, right? So we know it's female, so we only focus on the A column, right? So it's probability of A1, which is female, and pass the exam is B1. So this is the probability of B1 given A1. And this probability can be calculated by 0.5 divided by 0.6, right? So within all the ladies, the proportion of passing the exam, right? So it's going to be the probability B1 and A1 divided by the probability of A1. So you can see the conditional probability is calculated by the joint probability divided by marginal probability. So here is another thing that I want to mention for you to know, okay? And thirdly, in terms of the probability, you've also learned probability trees, right? Probability trees. Well, for those probability tree types questions, it's not happened so often in 5001 exam, but it did happen before in QBUS5002 exams. So you need to be able to not only draw the trees, but also label the trees correctly, okay? So for example, if we do have two pair of events, A and A naught, B and B complement, or B naught, okay? So if A is our prior probability, which happens here, so they can be probability we're reaching A and B, right? So this is A and this is not A. And given A already happened, here should be the result of A and B happening together, right? And here is A and B naught happening together. And this is A naught and B happening together. And this is A naught and B naught happening together. So here are the four different outcomes that we may observe. So in terms of the probability trees, this is probably the correct labeling of the probability trees. And you should also be able to calculate the probabilities based on the probability trees, okay? So for example, if we already know the probability of A is 0.4, okay? So for example, there is a kind of, well, let's consider A and B are different real life scenarios, okay? So A is if for a person who has a kind of disease like brain damage, okay? So the person who has brain damage, we'll call it A. So BM, brain damage. Not brain damage is non-A, okay? So we know that the proportion of people who has brain damage is 40%. Oh my God, 40% is too high, right? Okay. What about 4%, 0.04, okay? Just for illustration purpose. Okay, 0.04% of the person who's got a brain damage. And for B can be a test, like an IQ test, okay? It's a very basic IQ test, all right? So for the brain, so for IQ test, there are only two results, pass and fail, and not pass, right? But this is different from our QBUS5001 because our QBUS5002 has only pass, no fail, right? Unlike the IQ test. But anyway, what's going on? I don't think my computer is plugging in, but yeah, it should be working. But anyway, let's continue. So IQ test, if we denote pass as B, fail as B complement, then what we also know is that if a person has brain damage, what's the probability of pass the exam, right? So pass the exam, have brain damage is 0.2, for example. It's not very precise because sometimes they can still pass the exam by luck, right? So the B given A means if we already know somebody is brain damaged, and the probability of pass the IQ test, okay? And we also know that if somebody is not brain damaged, the probability of passing that exam is 0. For example, 7. So it can be high. Well, it's too low, right? 0.9. All right. So here are the basic informations that we are given in the question. So another thing that you need to know is to correctly labeling the probabilities on the probability trees. So from here to here, from start to A, we will experience the probability of A, right? And here is the probability of not A. So A is 0.04, not A will be 0.96, right? And we also know the probability of B given A and the B given A complement. Therefore, if A has already happened, then the probability of reaching this result is the probability of B given A. And here is the probability of non-B given A. And this is the probability of B given not A. And this is the probability of non-B given non-A, right? So here are the ways that we calculate the different, we label the different probabilities. And also in terms of the final results, so if we do not know A has already happened, what's the probability of being here, right? So this is going to be, stepwisely, you reach A first and then reach this A and B. Therefore, the probability of A and B can be calculated by the probability of A multiplied by the probability of B given A, right? So you can see joint probability can be calculated by the marginal probability times conditional probability. All right, so similar things happen to here, here, and here. So here are the ways of labeling the probability correctly as well. Now, finally, what can the question ask us in terms of the probability tree? So the question will ask, if we already know somebody who doesn't pass the exam, or who doesn't pass the IQ test, what's the probability of this person being a person who what do you think, brain damage or not damage, whatever you like, right? So for example, who failed the exam, but and he's also a brain damage. Okay, so usually for this type of probability tree question, you are usually given, for example, B given A, and you are asked A given B, right? So if you see this happen, then it's very likely you're asked to do a probability tree. All right. Okay, so that's all about the probability of A given B, and you're asked to do that, right? So A given B, A given B. So which means we are B complement. So we already know B complement happen, right? So here are the only two results that makes the B complement happen, right? So the denominator should be the probability of A and B naught plus A naught and B naught. And within these two branches, two scenarios, which one is brain damage? Which one? The first branch, right? Within those two branches, only the first branch is brain damage. Therefore, we use the probability of here, A intercept B, interception B naught. So here, so if you plug in all the numbers into this formula, you can get the result of A given B complement, right? So some of you might ask, how do I get those numbers? Well, as I said, those joint probabilities can be calculated if we are given A's probability and B given A's probability, right? So simply by multiply them together, and then you can get the probability of A and B. Similar to A and B naught, A naught and B, A naught and B naught, okay? So this is, I believe this is quite difficult but also very important aspect on your mid-semester exam, okay? So far, we finished the descriptive measures, probabilities, and we still have two things to go. One is the random variables and the probability distributions. And so again, you might have watched the video from 5001 review, right? The notification is on ED. So if you look into that, I explain it there in super details, okay? So in terms of random variables and probability distribution, as I said, you've learned discrete distributions, and you also learned continuous distributions. Okay, so for discrete distributions, you basically learned two things. One is binomial distribution, another is Poisson distribution. And for continuous distribution, you've learned uniform distribution. You've learned what else? You've learned exponential distribution. You also learned normal distribution. So for each of the distributions, if you really want to grasp them very well, I mentioned the 5 aspects that you need to know about each 5 distributions. So for each distribution, you need to know the following 5 aspects. So what are those 5 aspects? They are in another video stated in the links on Canvas. I think it's the part 3 live streaming for 5001 students. So I won't repeat doing that again, because I recommend you to watch that video before you come to today's revision session, right? So I won't bother explain that again, but I just want to let you know that knowing all those 5 aspects, then you will be you will be very happy with all types of distribution questions. So in that 5 aspects, in that topic, part 3, I guess, in that video, I also introduce how to get full mark, how to get full mark in that particular kind of distribution questions. So it's all about how you present your answers. Again, watch for those 2 contents, watch the video, watch the part 3 video link on ED. So on ED, I've posted the part 3 link. So after today's live streaming, you may find yourself go and watch those videos, and I believe they are extremely helpful for your 5002 exams as well, because 5001 and 2 are essentially the same thing. Okay. And for the 4th topic, the last one is the law of large numbers and central limit theorem. So you need to be able to understand what is law of large numbers and what is central limit theorem. So the law of large numbers, in order for you to understand law of large numbers, it is something like that. For example, if you flip a coin for 10 times, okay, 10 times flipping a coin, what are the possible results you can get? So it's very likely you can get 1 head and 9 tails, that sort of stuff, or 2 heads, 8 tails, this extreme conditions, right? But what if you increase this number to 1000 times flipping? So it's very unlikely to happen with 1 head and 999 tails, right? So this should more or less around 500 on each, right? And if you flip 1 billion, 1 trillion, 1 whatever lin, okay, coins, then I believe it's almost strictly equal to half whatever lin kind of occurrence of head and tails, right? Closer to 0.5. So this means when sample size is growing larger, we are more likely to get a precise estimate of the population parameters, okay? So that's basically about the law of large numbers, right? So in the application of statistics, this also worked. So if we want to estimate the population mean mu, right? So we can never reach the population mean mu. So we can only use sample mean x bar, right? But in the calculation of sample mean x bar, what's gonna happen is that when you increase the sample size, which is the increased sample size n, what do you think is going to happen to the precision of our estimation if the sample size is large? So if the sample size is large, then it's going to be more precise, right? It's going to be more precise. I mean, our estimation of x bar to estimate mu will be more precise as n increase. So in a mathematical way, we define x as a random variable who has already have a mean. The ex bar is always mu because x bar is an unbiased estimator of population mean mu, right? And at the same time, the variance of x bar is affected by the sample size, which is sigma square divided by n. Okay, so we can see the sample mean distribution. Well, the sample mean, some of you might not so understand x bar is already a mean, right? What is the mean of the mean? So expected value is just the mean, right? So this stands for mean of the sample mean is population mean. And variance of the sample mean is the population variance divided by n. So, well, I forgot to say the population variance is sigma square, okay? So here involves your understanding at x bar to be a random variable. So for example, if I have a population which contains 1, 2, 3, 4, 5 units, okay? So now what if I want to take a sample of size 2? If I want to take a sample of size 2, randomly, I may take 1 and 3, right? And you can see here the x bar equal 1.5. And if I randomly take 2 and 5 together, the x bar is 3.5. So you can see, every time we take a different sample, the sample mean can be different. Therefore, sample mean itself is actually to be defined as a random variable. That's why it has expected value and variance, okay? So you have to understand x bar as a random variable. So no matter what happens, the sample mean will always have a mean mu and the variance of sigma square over n. Okay, so this is one conclusion from our law of large numbers. So what can happen is a kind of question tells you that tells you what is mu, what is sigma square, and then it asks you to calculate the distribution of x bar, or it asks you to calculate the probability of the sample mean to be less than, for example, 10, that sort of question. So without distribution assumptions, you can never do that. But so far, you are able to calculate the expected value and variances of x bar, right? Now, as you may have noticed, I'm about to say how do we calculate the probability of x bar less than or greater or lie within each range. How do we calculate that probability? So if you still remember what you learned in, James Gu is there. Hi, James. Good to see you. But anyway, let's continue. X bar less than 10. If you do want to know that probability, what else you should know? If you could recall what we learned in probability distribution, once we fix a distribution, by plugging in the numbers, we are able to calculate this probability using the integral of the probability density function or cumulative distribution function, right? Therefore, in order to know this kind of probability, one more thing we need to know